6.3 Equations of Parallel and Perpendicular Lines. Alright, you had better know these first two things. We've talked about them so many times. What is true about the slopes of parallel lines? If two lines are parallel, right, like those, train tracks, never meet, never touch, never get closer together, never get further apart, what do you know? The slopes are exactly the same. How about perpendicular lines? Remember, perpendicular lines are lines that meet at a 90-degree angle. I don't know if I've drawn it perfectly, but there should be a 90-degree angle. That's where the lines met, is a 90-degree angle. And what do you know about those? Their slopes are negative reciprocals. I know I've done this many times. I'll do it again. If one of them has a slope of 1 over 3, then the perpendicular line would have a slope of 3 over 1, or just 3, and would also have to be negative, so it would be negative 3. These two lines, if they have these slopes, are perpendicular. If one's negative 2 over 5, the other one would be the reciprocal, 5 over 2, and it would be negative negative, which is positive. So they always are going to have different signs. Okay, we've done that multiple times, so I'm sure you're rolling your eyes and saying, why is he doing this again? Okay, what we're going to do in this today is we're going to find equations of parallel and perpendicular lines, and so here's the steps to do that, and then we'll do 3 questions and we're done. The first step is you're going to find the slope of the line you're already given in the question. Then you're going to use that slope to find the slope of the line you're trying to find. Then you're going to put it into point slope form, and then you're going to switch it to slope intercept and or standard form. Okay, so let's go through all those steps. The first step says find the slope of the line you're given in the question. I guess I should read the question first. It says, write the equation of a line that's parallel to this equation here. It's parallel to that equation, and which goes to the point 2, negative 5. Okay, so the first thing we need to do is, it says up here, we need to find the slope of the line you're given in the question. Here's the line we're given, 5x minus 2y equals 12, and we want to get the slope of that line. How can we do that? Well, there's 2 ways we could do it. One way we could do it is you could find the slope. Since this is in standard form, ax plus by equals c, we could do negative a over b. And if you do that, you get negative 5, that's your a value, over a b value of negative 2. And negative 5 over negative 2 is the same as 5 over 2. Of course, the other way you could have done this is you could have isolated the y. You could have turned it into slope-intercept form. But if you can memorize this formula, negative a over b, I guess this would definitely be easier. You've just found that your slope is 5 over 2. That's step 1. Step 2, use this slope, use the 5 over 2, to find the slope of the line you're trying to find. Okay, we want to find a line that's parallel to this line. Well, what do you know about lines that are parallel? They have the same slope. So, what we know is the slope, therefore, slope of the parallel line equals the same thing. It also equals 5 over 2. So what we have now is a question that asks, what's the equation of a line that has a slope of 5 over 2 and it goes to the point 2, negative 5? Hey, this is just like questions we've done before. What we're going to do now is we're going to put it into slope point form. Remember slope point form? Slope point form is y take away y1 equals m times x take away x1. And remember, I'll just highlight them here for you. Remember that this y will definitely be there. You're not going to put a number in there, and this x will definitely be there. You're not going to put a number in there. Those two letters will remain in your equation. So let's do that. We do y minus y1. Well, y is negative 5, so we're going y take away negative 5. That's y plus 5 equals m, that's the slope, and we know the slope, it's 5 over 2. Then we have x, that's the highlighted x that always is there, take away the x value, which is 2, so x take away 2. Okay, we're done. This is slope point form. But we don't want it to be in slope point form. We want it to be in either slope intercept or standard form. Let's switch it into both of them. So slope intercept form is y equals mx plus b, and standard form is ax plus by equals c. So let's switch it into slope intercept first. So we've got to get the y by itself. So we're going to move that 5 over, but the other thing we have to do is we have to expand this. We have to multiply the 5 over 2 times x and the 5 over 2 times negative 2. Mountains, as I call it. So let's do that first. So we still have y plus 5. We won't move the 5 yet. Equals 5 over 2 times x is 5 over 2x. And 5 over 2 times negative 2. Remember, that's the same as 2 over 1. So 5 times negative 2 is negative 10. And 2 times 1 is 2. Good. Now we'll move the 5 over. So we have 5 over 2x. Might as well simplify this. We're going to take away 10 over 2, which is 5. And then we're going to move this plus 5 over. It becomes another negative 5. Okay, let's do one last step here. Y equals 5 over 2x. Negative 5 take away another 5 is negative 10. Okay, this right here is slope-intercept form. Now let's switch it into standard form. To get standard form, you want no fractions. So this is the first problem, is we have fractions here. How are we going to get rid of the fractions? We take a look at the denominators. Well, the only denominator is 2. And what we're going to do is we're going to multiply every term by 2. So what we would get in the first one, 2 times y is 2y. 2 times this one. Well, when you multiply by 2, the 2's cancel. That's perfect, because then all we're left with is 5x. There's no more fraction. That's what we wanted. And we also have to multiply this by 2. So you get minus 20. Now remember, you want your a value to be positive, this 5. So it already is positive. Don't move it to the other side or you get negative 5x. So we're going to leave the 5x over here. We want to bring the 2y over, which will now become negative 2y. And we want to move the negative 20 over to the other side, it becomes 20. We've done this a bunch of times before, so I'm not going to spend too much time with this. You're done right there. Or if you want, you can make it, just switch the sides of them. So 5x minus 2y goes on the left and 20 goes on the right. This is standard form. Let's do another one. Write the equation of a line perpendicular to 2x minus y equals 4, and which goes through the point negative 6, negative 1. Okay, so the first step we said was to find the slope of the line you're given. Here's the line we're given. That's 2x minus y equals 4. We need to find the slope of that line. I tell you what, let's figure out the slope of this one by doing it the other way. Instead of doing, well, we'll do it both. All right, why not? Negative a over b. Negative a, well, the a value is 2, so it's negative 2. B, what's the b value? It's negative 1, so it's negative 1. Negative 2 over negative 1 is 2. Just to show you the other way you could have done it, or you always have this choice to do it in both of these ways if it's in standard form. If it's not in standard form, you're going to have to do it this way, which is to isolate the y. Easy way to isolate the y, just move the y to the other side. So that'll leave the 2x over here. We'll bring the 4 over, it'll become minus 4. And move the negative y over, it becomes y. There you go. This is now in, you can rewrite it like this if you want. This is now in slope-intercept form. So here's your slope right here. Slope is 2. Hey, that's what we got here too, 2. So the slope is definitely 2. And we know it goes through this point. Oh, but wait a minute, don't skip a step. This is the line we're given. What does this mean about a line that's perpendicular to this? So the slope of a perpendicular line if it's a line that's perpendicular to this line, it's perpendicular to this one. What's the slope of this line, the circled line? The slope of that one is 2. So the slope of the perpendicular line has to be the negative reciprocal of 2. So that means it is 1 over 2 for the reciprocal, and make it negative, so it's the negative reciprocal. So there you go. We're dealing with a slope of negative 1 over 2, and it goes to the point negative 6, negative 1. Okay, now we go through all our steps. First of all, we're going to put it into slope point form. So y minus the y value, which is negative 1. Y take away negative 1, that's y plus 1, equals the slope, which is negative 1/2. And then x take away the x value, so it's x take away negative 6, or x plus 6. That there is point slope. Now we want to turn it into slope-intercept, y equals mx plus b. We have to multiply these, do the mountains there. So we have y plus 1 equals negative 1/2 times x is negative 1/2 x. Negative 1/2 times 6, well this is 6 over 1, so negative 1 times 6, that's negative 6. And 2 times 1 is 2. Okay, good. So now we have y equals, we're going to move the plus 1 over, negative 1/2 x. Take away 6 divided by 2 is 3, and bring this plus 1 over, it becomes negative 1. So you get y equals negative 1/2 x minus 4. This is slope-intercept. Okay, if we want to turn it into standard form, we need to get rid of the fractions. So we look at our denominators. There's only one denominator, which is 2. We're going to multiply everything by 2. So it becomes 2y equals 2. If we multiply by 2, the 2's cancel. So we're just left with negative 1x. And multiply the negative 4 times 2, or minus 4, you get minus 8. Okay, we got to get the x's to be positive. Right now we have negative 1x. Why don't we move to the other side and make it positive 1x? Or instead of even positive 1x, why don't we just call it x? So we have x plus 2y equals negative 8. And this is standard form. There you go. Okay, last one. Write the equation of a line that is perpendicular to x plus 5y equals 9, and it has the same x-intercept as this equation. Oh, we got a couple things to worry about here. Okay, the first thing we better do again is find the slope of the line that we already know. We already know this line, and the one we're interested in is perpendicular to this one. So what's the slope of this line? Well, I know you like it. Let's use negative a over b. So that's negative, what's the a value? 1. And what's the b value? 5. Okay, therefore, the slope of a perpendicular line we want the perpendicular line has to be the negative reciprocal. So the reciprocal would be 5 over 1, or just 5. And since this one's negative, we'd make it negative negative or positive. So we're interested in a line that has a slope of 5, and it has the same x-intercept as this one. So we need to figure out the x-intercept of that. How do we do that? Okay, if we want to know the x-intercept of 3x plus 9y equals negative 12. What do you remember about x-intercepts? Well, if it's an x-intercept, remember it's a point that's right on the x-axis. And what's the same about all these points? They all have different x values, but what's the y value of every single one of these points? They all have a y value of 0. So what that means is, in order to solve this, to find the x-intercept, we put 0 in for the y. So we get 3x plus 9 times 0 equals negative 12. Or 3x, 9 times 0 is 0, we don't even need to write it, equals negative 12. Now we solve that. Divide by 3, x equals negative 4. So that means our x-intercept is at negative 4. Or if you want, the point is negative 4, 0. By the way, you certainly don't need to do this for this question, but what if the question didn't ask you, it didn't say it has the same x-intercept as blah blah blah, what if it said it had the same y-intercept? There are some questions that say this, so let me just show you how you'd get the y-intercept. It's very, very similar. If you wanted to get the y-intercept of 3x plus 9y equals negative 12, you'd be looking at points on the y-axis, like these points. Now, what's the same about these points? They all have different y values, but they all have the same x value. What's the x value of all these points? The x value is 0. So you'd put 0 into the x to find the y-intercept. So you put 0 in right there. Plus 9y equals negative 12. 3 times 0 is 0, so that's gone. 9y equals negative 12. Divide both of them by 9. So you get 9 divided by 9 cancels out, because that equals 1. And negative 12 divided by 9, which you can put in lowest terms, negative 4 over 3. So your y-intercept is 0 and negative 4 over 3. It's kind of an ugly y-intercept, but that's what you would do. Okay, so it's important that you know how to get the x-intercept and also how to get the y-intercept. It's kind of like before when we were graphing lines in standard form and we made that little table that looked like this. x, y, and then we said 0 for x and 0 for y. Why did we do that? Because when we put 0 into the x, we figured out this number, and that was the y-intercept. And when we put 0 into y, we figured out this number, and that was the x-intercept. Remember doing that? I hope so. That was when we were doing standard form. Okay, so what are we down to? Or what are we working with here now? We have a line that has a slope of 5, and it goes through the point negative 4, 0. So now we do the same old thing we've been doing time and time again. We first of all put that into our slope point form. Okay, so y minus the y value, which is 0, y minus 0, equals the slope. What did we say the slope was? 5 right there. So equals 5. And then x minus the x value, which is negative 4. X take away negative 4. That's x plus 4. Okay, this y take away 0. We don't have to worry about it. If you're taking away nothing, you don't have to worry about it. So all we're left with on this side is y. That's great. And then all we have to do over here is the mountains, and we're going to be done. So first of all, I guess I'm getting ahead of myself. This that I had already done here was point slope form. Is it? I always forget. Is it point slope form or slope point form? I can't remember. I think I named it one. Here I called it point slope, and here I called it slope point. I'm sorry. I can't even remember which way it's supposed to be. Slope point, probably. Who cares? As long as it's a point and a slope, it doesn't matter the order. So this is point slope form, or slope point form. And now we're changing it into slope intercept. So y take away 0, I don't have to worry about the 0, so just y. 5 times x is 5x. And 5 times 4 is 20. What do you know? That's already, right here, in slope intercept form. Nice. The slope is 5 right there, and the y-intercept is 20. Now I want to put it in standard form. That's also pretty easy. All you have to do is, there's no fractions here, so that's great. You don't have to multiply by anything. You want to keep the x's positive, so keep the 5x on this side, the right side. Better bring the y over, because it has to be on the same side as the x, so it's going to become negative y. And move the 20 to the other side, negative 20. There you go, you're done. If you want, you can switch the order of them. 5x minus y equals negative 20. This is standard form. Okay, there you go. Very common questions, definitely on the provincial exam. They're going to give you a question or two just like this, where it talks about perpendicular to a certain line and goes through this point, find the equation. It will be there, so make sure that you understand how to do these questions. And I'm sorry about the point slope point problem. I'll try to do better next time.